Good afternoon. I'm so glad that I'm here to present with my colleagues Santorini Caldera. Let's go back to Greece, to the Mediterranean Sea. For us, it's iconic caldera, so we are so glad that it is listed in 100 USGS geological sites. So as I said before, it's an iconic caldera in the Mediterranean Sea formed by Plinian eruptions in a volcanic architectonic framework, and I will prove why we say that. So in the application, except of me, as Nomikou Paraskevi from the University of Athens, there are two other geologists, Haralambos Fasoulas from Crete, and of course Nicolas Zouros from the University of Aegean, that all of us submit this application. Of course, so as I said before, this volcano is located in the South Aegean Sea. This is Santorini. In Greece, we have 4 volcanic groups, started from the west, Methana, and then we have Milos, Santorini just in the center of the Aegean volcanic arc, and of course, at the eastern part, we have Nisyros. Of course, if you fly above Santorini, you can see and admire the very beautiful, there's a video over there if you want to play. There's a video over there. Just click on the video. Okay. If you fly in the caldera, you can see the beautiful shape of this iconic caldera. Okay, so you need to have luck and, of course, to see the beautiful view. And, of course, it is located, as I said before, in a very active tectonic framework. We have within a rift basin. We have 3 main volcanic centers, starting from the west is Christiana. This is Christiana. Then we have Santorini, all the islands around Santorini, and of course we have Colombo. This is a very active submarine volcano, just 7 kilometers northeast of Santorini. For us, Santorini has different names, started from Strogili, in Greek means round, and of course my best name is Kallisti, which means the most beautiful. And of course, we have mapped the area very well, so we know what is happening on the seafloor, and we know the seafloor morphology of Santorini. Okay, so we are very glad because lots of geologists are occupied with geology, and one of them is Tim Druitt from University of Clermont, and he has prepared and published, of course, the geological map. So we know what is happening on land, and that's why we use various geological maps like this one. And to tell you the truth, if you are looking here, it has a very simple geology, but if you look here on the northern part, it has lots of different volcanic formation. So there are different volcanic centers. As we say to the students also, Santorini is not only one volcano. Santorini has lots of different volcanic centers starting from the age of 650,000 years before. And of course, we are also lucky because they have dated all of these different volcanic formation using argon, and of course potassium, argon. And we have lots of Plinian eruption. We have 12 over the last 300,000 years. And of course, we have that erupted several tens of cubic kilometers. And of course, we have either Plinian periods like the one that we are here, and we are just in Nea Kameni. If you are in Caldera, you can look and you can, it's like a Grand Canyon, we may say, in the Mediterranean Sea, because each layer represents a different volcanic eruption. For here, for example, starting from 360,000 years, and then you have the last eruption, the Minon eruption, the biggest eruption of the Mediterranean Sea that was occurred 3,600 years ago. Okay, so for us, Caldera, Santorini Caldera, has it's a multi-cyclic caldera, so we have multiple collapses. And here we present only 3 of them, but we know that there were 4 collapses. And if you look on the isopach maps of the Plinian eruption, you can understand that all these different type of vents are concentrated just in the middle of the caldera. And the caldera, the different types of caldera, they were exactly or almost the same shape that it is now. And of course, there are 2 tectonic lines. As we said, this is Colombo line and this is Kameni line. So all the vents are located along this Kameni line. Okay, so this is one of our beautiful photo in the stratigraphy. This is the northern part of Caldera. You can see lots of dikes that they are cut, all the stratigraphy of Peristera volcano, a very, very old volcano. So it is outstanding that the stratigraphy of the volcanic rocks of multiple eruptive episodes is evident in fire caldera walls. Okay, so you can see that except of land, we need to investigate what is happening on the seafloor. So we map the area very precisely, and we figured out that before the Minion eruption or during the Minion eruption, the caldera was not was dry, was not connected with the sea at all. So for us, the tsunami that was created during the Minion eruption was generated by pyroclastic flows that entered violently into the sea and not due to the caldera collapse. And of course, the well-known Minion eruption for us is late Bronze Age eruption. It has 4 phases, started from precursory explosion. It has buried completely one of the biggest ports at that time. This is Quaternary. For us is Pompei, the Aegean Pompei. This is located in the southern part of the island. And of course, the yellow color indicates the pyroclastic flows that enter into the sea around Santorini caldera. And of course, phase 1 is the Plinian fallout. Phase 2 and phase 3, these are the phreatomagmatic eruption. And the most destructive eruptive phase was phase 4 with the Ingrid hot pyroclastic flows. Also, what we are doing the last years, we try to reconstruct the shape of the caldera before the Minion eruption. And we try to figure out the size and the geometry of this pre-Kameni volcano here, just in the center of the caldera. So using some analysis, we figure out that the volume of this Kameni volcano was only 2.3 cubic, has the volume of 2.3 cubic kilometers. And of course, we do some other analysis. For example, here we know that at the northern part, there are old cliffs that indicate that this is the oldest caldera, and all of these caldera cliffs are all located after the Minion eruption. After the Minion eruption, the destructive Minion eruption, everything started from the seafloor. So we have, again, the reconstruction of some volcanic centers just in the middle of the caldera. So from 197 BC up to 1950, this is the last eruption, this is the newest land of Greece. We have multiple eruptive episodes, so we have the creation of Nea Kameni, and just at the back, it's Palea Kameni. We have lots of reports, we have lots of photos, and lots of histographs, and all of them indicate the eruptions, that all of the types are Vulcanian type and not Plinian type. So this is the site of the recent caldera. The deepest part is 390, just at the northern part, and this is the south basin at the depth of 270, and this is the western basin at 320. So you can see here that the volume on land of this Nea Kameni and Palea Kameni, it's only 2.3. But if you measure all the lavas that you can find on the seafloor, so the volume of Nea and Palea Kameni is 3.2 cubic kilometers. And of course, because of this importance of Santorini, in 2015, we have Santorini active experiment. We deployed OBS around Santorini, and in order to indicate the geometry of the magmatic chamber below Nea Kameni. And of course, the first results up to the depth of 6 kilometers, we found that all the pressure sources are indicated just at the northern part of Nea Kameni. This is the pressure source of 2011-2012 Santorini unrest, and all of these are the vents of the previous volcanic eruptions. And what else? We have dived within the caldera, and we have found lots of microbial mats and a lot of CO2 pools just on the northern part of the caldera. So this is the area, as you can see here on the map. This is very active. This is the Colombo line. Just at the northern part of the caldera, we have found this microbial mat. So this is the site that we need to monitor in order to indicate the activation of a new eruption. And of course, just for the story, we are lucky because lots of scientists all around the world, they have studied the on-land stratigraphy. So we have geological map, we have detailed volcanic stratigraphy, we have large database of potassium argum, technostratigraphic dates, basic petrological, geochemical, and multi-isotopic characterization. We have melt inclusion and all of that. This is land. But what is happening on the seafloor? Hopefully we have swath mapping, we have lots of geophysical surveys, ROV exploration using different types of ROVs and AUVs. So we have lots of different types of cores and dredging. And of course, just in a few days, in a few months, in December 10th of December of 2022. Within the caldera, we are going to have the IODP, I know, 3 minutes, IODP expedition. So these are the questions that it will be addressed by drilling. For us, we will drill in 2 sites, the northern part of the caldera and the southern part of the caldera. This is geodesic resolution that will come in the Mediterranean Sea, in the Aegean Sea, and we need to drill. This is the northern part, this is the southern part. We need to drill in these specific places because we want to find out where are the volcanic layers of the Minoan eruptions. One of the reasons. And of course, this is an outstanding view of, this is a Daphne crater in Nea Kameni, and you can see the beautiful formations. This is Karos, the beautiful formation of Santorini caldera. And just to sum up, these are all the reasons, I'm not going to read it, don't forget, don't worry. These are all the reasons why we believe that Santorini caldera is an iconic site in volcanology and of course in archaeology. This is 15, a major training ground for volcanologists and archaeologists for universities all over the world. So during the whole year, we have lots of universities. We organize summer schools, and there are students from all over the world that they have studied not only the on-land geology, but now also the offshore geology. And of course, Santorini is very, very, very famous of the sunset. So this is one of the most beautiful pictures that you can take from Fyra. And Efcharisto Poli, that means thank you so much. Thanks.